Good morning. Before we start, you can turn to page 206 and try out class practice 33.4. Page 206, practice 33.4. Now, please start doing this, and we would like to check your understanding of this topic soon. Anyone who see 唔看一？好。鄧進於鄧浩俊。鄧浩俊、黃奕朗 and 吳漢一 are you here? All right, so good morning. Now turn to page 206 to have a recap of the topic covered last week. We talked about condensation polymer, and I posted the comparison table between the condensation polymer and the shrimp polymer together, so you as a reference. So this is a very authentic example of condensation polymer, which we have got two types of monomers with bifunctional group at both ends. Can you see that? We've got two functional groups at both ends. So very typical example of this. Name the functional group made during the formation of the polymer. Made. Okay, take a look at the term made. Anyone who can tell? Ester linkage. Okay, ester linkage. So I say it as ester, which means that you retrace back to the original chemicals. Okay, for the original chemicals, we have got alcohol, a hydroxy group, and one carboxyl group. So write the chemical equation for the formation of this polymer. If I a long one, how will you present this? How will you present this? You're going to stick back to we've got one example underneath, right? How we draw? Now we have got this N plus N, okay, to form a polyester. So my focus is on how you draw the polymer, the structure of polymer web. So you may mark, you may split this like this way. I would like to change the color of the linkage so as to you can trace back more easily. So this is carboxyl. This is another carboxyl. So you use this one as example. So we have got carboxyl and hydroxy group. So you are going to have a condensation reaction, okay, to remove water. So you use this and you may draw something like this. And then O, okay. And then you're going to draw this. And then what? I need to shrink a little bit, otherwise it's too long. And then what? 1, 2, 3, 4, you could draw a W here. W, okay. So originally it would be this, but you just form only one ester. Okay, so what you do next is to think it like this way. Suppose on the left-hand side, for the hydroxy group, this one H will be removed. So which means that you think it for the another ester linkage that will form, the H will be removed. Similarly, for the OH here, it will be removed on the other side when you have a hydroxy group nearby. Can you get my point? So what is the hidden message? So the water will be eliminated like this way. So you just remove this and also remove this H and OH. So remember, you are going to remove one H, one OH, one H2O. So by doing so, you can have this. So what should be done finally? Lengthen the bond. Lengthen it. And then for this, how about this? You're going to lengthen it as well. And finally put a middle bracket here. When put it, is it clear? So this is what we tried out how to do the to make the condensation polymer with a certain repeating unit shown here. So of course, you may also put this, shrink it. Okay, this is the proper way to draw the formula. Okay. So what is left behind now? Because you are going to draw the chemical equation, not organic synthesis. Chemical equation. So something is missing. Water. So you mark this one as the final answer, 2N minus 1 H2O. Why is it 2N minus 1? This is something about mathematics, right? For those who study M1 or M2, you know something about induction, right? So you have got two molecules that merge together, they would have one water molecules eliminated. Okay, you base on this. How about three monomers attached together? We've got two water molecules to be eliminated. So in case we have got 2N, right? Because each of the monomer we've got N molecules. So I miss out this one, N, and then middle pass. Okay, N hydroxy group. We've got N carboxyl group, couplet substance dicarboxyl group compound. So altogether we've got 2N minus 1 H2O. So each time the connecting ester linkage will cause one water elimination. So you have got 2n-1 as the answer. Do you get what I mean? So any more questions about that? If not, now here comes question 2. The section of polymer is shown below. Write the structural formula of the two monomers formed to make that polymer, and what small molecules will be limited during the formation of this polymer. Okay, it depends on the what monomers you're drawing before you answer B. It can be various answers, it's not just H2O. But if you use the most common way, commonly appear method in DSE syllabus, and usually water is an elimination product. So the two monomers, it is a diol and then with a dicarboxylic acid. Right, we have got the two, diol and dicarboxylic acid. So how will you get the answer? Can you find out the two original materials inside? How will you chop? Now, what I mean is, well, how will you chop that two substances? Now, for example, if you start this one as a start, okay? So you may find the ester linkage, right? Ester linkage. So you chop the ester. You try to break down the ester linkage bond. So what will you get? What will you get is on the two original materials. This one, it seems like carboxylic acid. And this one, it is carboxylic acid. Can you see that? So leaving behind is on this, it is a, it's dicarboxylic acid. I need to mark it one more point, is dicarboxylic acid. How about this? This is a diol. So you may find this one is a diol. This one is a diol. Can you see that? So in other words, if you want to talk about diol, is here, diol. Can you find it? Diol. Diol. Exit. Exit. Like this. Okay. So reverse of the esterification process, we call it hydrolysis. So what should be done next is to cross out the bond. You're going to remove the bond. Remove the bond here. And what should be added? H2O, right? So how you add? So you add H here, and you add OH. Similarly, you add OH and mark it as H here. So it is the way we add back those water. Now, here comes, if you do the same tricks, you may get this. You do the same thing. It's OH, right? Indeed, it's OH. How about this part? This is becoming a hydroxy group. It is hydroxy group now. Okay, so you do the same similar way. So we focus on these two, right? Can you get the two monomers now? Now, indeed, it seems like a changing in the position, right, of this. We've got that two of very strange monomer. This one is quite different from what we usually see. But this one is the axiphol. The other one is the alcohol. Okay, we have got two hydroxy groups at both ends, while for this, we have got two carboxyl group at both ends. So that is the answer. Any questions? For those who can follow, please put a tick. If not across, let me know now. How about the others? Okay. 張思慧學校日里程，譚君柔 and 黃成軒 ，Can you follow？ 張思慧里程，譚君柔講。Now I'll keep on calling your name. Now, and we have got a daily application of that polymer. Is a type of, we call it polylactide, PLA. Have you ever heard of this? PLA. The one you use it in 3D printer. You use it. Now, Jun, do you know what it is? So the raw materials of making this is lactic acid. So we will call that a polylactic acid, right? The lactic acid is just a original substances. So by having the making of this PLA polymer, it is said to be biodegradable. Now, what to compare with the some other synthetic polymers? Usually, you describe as non-biodegradable. The biodegradable, which means that it can be broken down into microorganisms. So this is the structure of the lactic acid. One lactic acid is here, right? So we have got one hydroxy group and one carboxyl group. So similarly, you may do the same tricks. You may find a hydroxy group, if a neighboring hydroxy group and the neighboring carboxyl group, they would merge together to form an ester linkage. So you may find the ester here. The ester here, right? Can you see that? So with the elimination of water, so this is a very special case about it is also called it as condensation polymer. Okay, but this time we have got one type of monomers with two different functional groups at both ends. Now, this is different from what we mentioned about the previous case. In the class practice 33.4, we need to have two types of monomer. Each type of monomers are bifunctional, right? They bear the same functional group, or same type of functional group, but we have got two functional groups of the same type. Okay, is it clear? So this is what we record it as a type of polyester. And lactic acid is a naturally occurring substance, which is manufactured. It can be manufactured industrially by the fermentation of some food. Okay, for example, cornstarch or sugar. And polylactide, why you say that it's a biodegradable substance is because of the is it prone to hydrolysis by the chemicals or by enzymes to reform the lactic acid, and it can be easily metabolized by the living matter into carbon dioxide and water. Now, which means that if you use this, right, temporarily in the short term, it still serves the purpose of a polymer. But if you bury underground, for example, if I put even I put it into air for quite a long time, this PLA polymer will decompose. Right? As long as we have got the suitable conditions and the chemical or enzyme which will help hydrolyze the ester. So the PLA will be finally degraded. So this is said to be a more environmental friendly material. Okay, so this is what we will know it as PLA. So the use of PLA, besides you use 3D printer to have the model, you may also use it to replace some bottles, disposable cups, textiles. Okay, and also in component of self-dissolving stitches in medicine. So we call this one, identify the functional group of polylactide. As said before, ester group. Repeating unit of PLA, I would like to ask you guys to tell me what is the repeating unit of PLA. Now you chop ester and ester, right? How we chop this and this, right? First of all, you chop this one and this one, and we repeat. So later on, this OH will be reacted, right? Just like the one above. While OH group here will also be removed. Okay, not this one. So you may get the structure of the polyester. Okay, what I've just confined is the structure of the repeating unit. These three units, they are the same, right? So this is what we call that repeating unit. Draw it again. O, C, H, CH3, C double one O. Now this is the repeating unit. Now, and here, please do not draw it here. And no need. Okay? No need to draw N here. We are talking about repeating unit. But not the structure of the polymer. State the type of intermolecular force that will hold the polymer chains of polylactide together. Do you know the type of an intermolecular force that hold the polymer chains of polylactide together?
Van der Waals forces.
Van der Waals force. Yes, that's right. Van der Waals force. Okay, this is a type of van der Waals force. No hydrogen bond. There is no hydrogen bond because there is no slightly positive charge of hydrogen. Okay, no naked hydrogen here. So even though you talk about the H is not directly attached to high electronegative element NOF. No, so it is no naked hydrogen, no hydrogen bond, just a van der Waals force. Some people suggest, from the perspective of environmental protection, switching from using PET to PLA in making bottles for mineral water supplies a potential problem of widely replacing PEA by PLA. Widely replacing. Okay. What do you think? Lei Chen. From the perspective of environmental issue, it seems that you need to think of another issue, right? Other than environmental issues.
It is easily hydrolyzed. So it is not as durable as PET.
PET easily hydrolyzed when you compare PEA. Now, actually, PET and PLA also they have ester linkage. So, what is mean by easily hydrolyzed? So, what makes a difference between a used PEA bottle and PLA bottle? Now, we need to think of shelf life, right? How long we can place the bottle, the mineral water in the bottle. So it really depends on the minerals found inside the mineral water. Now, if the mineral water is slightly alkaline, okay, it's slightly alkaline, but it will be problematic. So this will be more easily hydrolyzed. In case or the bottle it is contaminated, okay, contaminated with some other material, microorganisms, for example, right? This will be easily hydrolyzed. But we have got one more potential problem is to think it backward to the production, okay? Because the PLA, the raw materials, is made from the agricultural products. Something like crops, right? So you are going to affect the supply the food supply indeed. Now it seems like what? It seems like in the past, people would argue about blending the petrol with gas with ethanol to form gasohol. So it is gasohol, it is blended with alcohol. Right? While the alcohol people will think of a mass production, so the ethanol is made from the fermentation of crops, just like corn. So it is once one of the application by some countries, not just like USA. Right? But you may think of how about the the other developing countries, right? So you are while those people, they are now starving for those food, right? On some developed countries, they try to turn this into some other uses. Okay, so it is a argument, but it is also a way for us to explore, right? To change the use to a more biodegradable materials, right? Because on the other hand, you need to think of the landfill issues, right? You think that we are now entering a stage of dilemma. So this is what we talk about as science technology for life. So that's why we usually talk about how many hour principle, right? So this is what you would talk about polyester. Any questions? Now, if not, we come to polyamides. We come to polyamides. Now, polyamide in it is indeed we also find this in naturally occurring substances in protein. Okay, we call it polypeptide. We have got a bundle, right, of 4 or more polypeptides that come together to form a big molecule. We call it protein molecule. So indeed, people have also make this polyamide, but we are not. It is served for different purpose, especially for fabrics design. So it is polyamide. So you may find this term nylon. It is a artificial man-made polymer. Okay, now we have nylon 66. So polyamide, if you take a look at the term poly, which means so many, how about amide? The amide linkage, we have got this. Okay, this is amide. COONH. So that's why I would like to show you another video for making nylon. Just wait for me. Nylon.
Now we are going to prepare nylon, which is a widely used condensation polymer. The 2 monomers we use are hexane 1,6-diamine and decane-dioyl dichloride.
Now, the 2 chemicals, they are different. Now, please take a look. Now, if you read the one on the book, we would have hexane dioic acid, but not hexane dioyl dichloride. Do you see the difference? While the amine, they are the same, hexane 1,6-diamine. So, what is the difference between the 2? Now, acid chloride and acid carboxyl group. Gentlemen, do you know? Acid chloride and acid. In terms of reactivity, do you know the difference? Anyone know? Now you better, all of you, please search on the web. Tell me which one is more reactive. Anyone know? Now, while you're searching, I would like to play the video again. And take a look on the elimination product. Okay, it is HCl. It's not water.
First, place hexane 1,6-diamine that has been dissolved in aqueous sodium carbonate solution into a small beaker. Now carefully add decanediol dichloride solution to the hexane 1,6-diamine solution. We can see that there are two immiscible layers. The white film formed between the layers is nylon. Use forceps to pick up the film formed at the interface of the two layers of solution. Hook the nylon thread onto a glass rod. Keep turning the rod to draw the nylon formed. Examine the appearance of the product. The nylon formed is a white polymer with high tensile strength.
So a very simple experiment. We talk this. So the making of nylon is by having two layers, right? One with a reactant A, one with a reactant B, while when the junctions, while the two solutions meet, it is the production of nylon. So they will pour. You may pick it up and you try to turn, okay, to form the nylon. As long as you remove the layer, right, of the nylon, that two chemicals meet again, and they will continuously form the nylon. So this is a very funny experiment about the making of nylon. Now, remember, for making the chemicals, we will also use what? This is also possible. Hexane diol chloride. Okay. So which one is more reactive? Is that something you know? What is mean by hexane diol chloride? So it is a type of acid chloride. Okay, acid chloride, if you compare it with the reactivity, it is more reactive, this one. Or you may see somebody will use the word dichloride, dichloride to tell. So it is a more reactive species. So it is a combination of this to this or this to this. If you react with these two, okay, they would have HCl, it is eliminated. But if you react that two, water, it is eliminated. So if you want to get to know the reason why, right, you are going to circle the corresponding chemical to eliminate the water, right? So finally you will form an ester. It's not ester, it's amide. So Similarly, if you do such, you are going to make an 8 removal HCl. Right? Only by doing so, you can get C double bond ONH. Okay. What's more, if you take a look at the term 6,6, it's very strange. 1,6 refers to the a number of carbon atoms in each monomer molecules, while the first 6 refer to amine. While the second 6, they will usually refer to the dicarboxylic acid. So if you take a look at the commercial market, you may also get some other chemicals, just like nylon 610, for example. Now, if that is the case, can you draw me the raw materials of making nylon 610? What I mean is the monomer. I just stop at monomers. What are those two? What are those two? Can you show me the name of the two? Can you tell me what are the two chemicals? Nylon 610.
Hexane 1,6-diamine.
Yes. Hexane 1,6-diamine and what is mean by tan? How we call
Decane acid.
Yes, decane acid. Very good. Decane dioic acid. That which means tan. So we have got that two chemical. Hexane 1,6-diamine. So be aware of what you are drawing, right? So you will want to talk about hexane 1,6-diamine, decane dioic acid. Now, why do I say so? It's because of the counting of carbon atom. For hexane 1,6-diamine hex, here 6 carbon, they are all counted in this 1H2 unit. But if you want to count the decane dioic acid, the DEC, now you are going to add that 2. You need to include that 2 carbon while you count the total number of carbon 10, which means that for CH unit, CH2 unit, we just have 2. Remember to allow 2 more units, 1 for each carboxyl group, to be counted as 1 carbon. Otherwise, you are making more than 10 carbon in this substance. Now, please take a look on that. Now, remember to count the carbon of atoms throughout the whole structure of the molecule to make sure that it is correct. Remember that means 10 carbon. So we have got 8 CH2 unit, we've got 8 carbon, 9 and 10 carbon. Is that clear? Now, so this is what I would like to draw attention to. Now, very strange. Now, if you how would you draw this polymer structure? As I said before, you are forming ester 8-mite linkage with the elimination of water molecules. So you may have got 1 H from H2, 1 OH group from carboxyl group, the acid. All together they merge, they will have water. So with the 2 units, they would have 1 water eliminated. So altogether, if you want to count the overall chemical equation, you may find that again, 2n - 1 water will be eliminated. While for the repeating unit, you are going to get rid of H2O, right? So you're going to cross this one. You do this similarly, okay, and such that you are going to combine the two, so that you can get this structure. Remember, put an N here, okay? With N, it is a structure of polymer. Without N, it is just a repeating unit. 8-mite linkage is found on here. But indeed, this is also the 8-mite linkage, but half of the 8-mite linkage is another half of the 8-mite linkage. Remember, our 8-mite linkage is C-double-bond-NH. Now, what is so special about nylon is that we have got this one, the rock primers will use a nylon thread because the nylon at the same time have a low density, but it can also have a very high strength. Okay, such that you can use it as a climbing ropes. All of you please underline it. Fishing lines will use nylon. Also, nylon can be used in the fabrics in the clothing industry. Okay, but once you wear the nylon as a fabric of the clothes, you may find that the texture of nylon is rather rigid. It's rather tough. Under what situation we have got nylon as a clothes material, clothes fabrics? For example, the blazers. Some of the blazers, right? The outer layer, it is the makeup of nylon. Do you know why? It's tough, and also nylon can be used as a material of making poster. Okay. So what I mean is a banner, right? The plastic banner. They'll usually use this. Okay, it's because they are quite waterproof. Do you know it? It's quite waterproof. So we usually use this. And why you say that nylon is a very strong material is because of the intermolecular force that hold the chain together. Is one of the polymer chain, is another polymer chain. In between both polymer chain, it is connected. Besides van der Waals force, here comes hydrogen bond. Hydrogen bond is found here because of what? This one, it is delta plus, well, which connect to the high electronegative atom nitrogen. That hydrogen will be connected to another oxygen from the 8-mite linkage by hydrogen bond. Okay, it is delta minus. So you may find similarly for this delta plus, delta minus here, right? So it is our way to form the hydrogen bond. And that's why this materials is said to be quite strong. It's quite strong. 8-mites can also undergo hydrolysis in acidic or alkaline condition. Okay. If you want to break down polyamide in acid, it is faster than alkaline solution. So that's why if you wash the nylon clothes, never wash it with acid, because after washing for a long time, it will cause some holes in the clothing. Now, one more thing I would like to add about the hydrogen bond and polyamide is on the structure of protein. Now, indeed, if you take a look on the protein structure, you may find there are so many different ways in which the protein is formed. Now, one of them, we call it is a beta sheets, alpha helix. Have you ever heard of that? So all those, they will show you the basic structure of the protein. So you may find the alpha helix, which means that the helix, the spiral up. If you take a look on the top wheel, it spiral up in the anti-clockwise direction. We call it alpha helix. If you don't understand, you may use your right hand. Okay, you crawl it at this position. You may find that you are going to have a it seems like a turning of an spiral position in the anti-clockwise direction. Beta sheets, okay, it is a part of the structure in which they will form like the sheets, and in between the two amide chain, where they are connected by hydrogen bond. So because of that, you may have the structure of protein of different way. So I would like to show you the protein structure. For example, you may see the protein structure having this, right? You may find that, wow, very nasty way is something about the you may see these two at the same time into your structure. Alpha helix, beta sheets, and what is said as a tertiary structure. So they will stack together, they will clump together, in which part of the structure being held by the hydrogen bond and some other structure, just like this. Because of this, alpha helix, beta sheets, tertiary structure, and finally they form a quaternary protein structure, in which the protein they will consist of more than one polypeptide chain that clump together. But indeed, it is not made it by random. Okay, depending on the different functions of the protein. For example, enzyme is a very true examples of a protein in which it is a carefully designed shape, okay, in which it will catalyze certain type of reactions, which is very important in our human metabolism. Now, for those who study biology, you may get to know what I mean. Okay, this is something about biology. Any questions? It's your turn. 33.5. Class practice 33.5. Nylon 4,6 can be formed from the reaction between butane 1,4-dioxide and hexane dioxide. Name the functional group made during the formation of nylon 4,6. It's amide. As said many times, it is amide. Amide functional group. So write the chemical equation for the formation of nylon 4,6. Nylon 4,6. Remember, 4 refer to amine. While the exit is hexane dioxide. So you will see through 4, but not 6. Remember, it's not 4. It's 4, not 6. Now, because you need to count the carboxyl group having carbon. And then altogether, we've got then 8 linkage. As I said before, something will be eliminated. That is water. So similarly, this one we will get rid of finally. So what you need to do is to draw the whole structure like this. NH CH2 bracket 4 and H C double bond O and then CH2 4 C double bond O like this. Maybe to some people who want to make it more easily observable, somebody will put an H here underneath. Now it doesn't matter because this single bond can be rotated. Okay, so you twist the end here, it is also fine. Now similarly, people would you may find some other answers like this. With a CO double bond, you put it down to show the later linkage. You got amide, right? Even though you draw this one, amide, it is also the same as this. They are the same. Okay. What is left behind? Water. So we have got 2n minus 1. Water is formed. Do you understand? Now, you need more practice on drawing the structure of the repeating unit. Identify the attractive forces between the polymer chains. 2 types of forces are found here. On top of what? Van der Waals force. We have got hydrogen bond as well. As said, there are the condition of formation of hydrogen bond in between the polymer chain. With the amide group with the NH, the H is H atom is directly attached to high E electronegative nitrogen. With the H, it will form a hydrogen bond with a neighboring polymer chain with a CO double bond with the O group. Because O is a high E electronegative element with the lone pair electrons. So there is a hydrogen bond in between. Questions? Any questions? Now we come to a brief summary of today's lecture. Well, we have come up with a condensation polymer with 2 examples. One is polyester, the other one is polyamide. Condensation polymer, which means that it is a chemical, a very big molecule made up of many small molecules. We call them monomer molecules. They join together repeatedly. By what? By condensation reaction. Okay, but at the same time, because we call it a condensation reaction, we have got the elimination of small molecules. Most of the time, right, we talk about water. But of course, if I changed the carboxylic acid to acid chloride, the elimination product is not water, it's HCl. For polyester, the linkage is ester linkage, while the polyamide, of course, the linkage is amide. Recognize the 2. Recognize the two. While you talk about the combination for making polyester is made of dicarboxylic and diol. Okay, while you talk about the amide is usually made up of dicarboxylic and then diamine. The repeating unit of it will be shown. Remember, this one is ester, but also this part is also an ester linkage, but part of that. So if you read it from another angle, you may find this one being a carboxylic acid, dicarboxylic acid, while this is from diol. Similarly, if we take a look on amide, you chop here, it's just part of the amide linkage. The whole thing is amide linkage, right? You chop here, you may find the original substance. It is dicarboxylic acid, while this one is diamine. Okay. Comparing the two chemicals, both they can be hydrolyzed by acid and alkaline. Okay, because the ester linkage and amide linkage can be hydrolyzed in acidic medium or and alkaline medium, respectively. Last but not least is used to compare the two chemicals in terms of strength. Nylon, in general, they have a higher strength. It's because of a hydrogen bond that can be formed in between both polymer chains, but not polyester. So if you really want to make the polyester more rigid, okay, you are going to think of how to add more benzene or length in between in order to make the whole structure more rigid. And this is our way to do so. Questions? Now, we come to to those polymers. We have got the questions about polymer as 19, 20, 21, 22, 23, 24. Okay, we've got that for that several questions about polyester and polyamide. Now, because time is running short, just 6 minutes left. We'd like to do two of them. One is polyester and one is polyamide, to have a overall conclusion about this. Let's take a look. Well, how about 20? PET is a synthetic polymer can be used to make the bottle for the carbonated drinks. Can you see that? So identify the functional group in this polymer. What is it? 馮家謙。馮家謙咪約。I didn't hear you. 馮家謙 ，Hello。
係諗緊啊，咩有個
group of this polymer.
PET
Any functional group that you can recognize here?
CO， 我見到佢有 COO 啫。
Yes. What is that? How we call it?
CO 冇 ester
Yes, this is ester. Ester functional group, ester linkage. Write the structural formula of the two monomers that can be polymerized to PET.
係咪斬開佢一半
Yes, and then
？And then
like this, okay? Use an ester, chop it into half, and then what? You add water back. Okay, similarly, you add water back and you can find out the two structure. H2O, right? OH, I add it into this and H is here. Similarly, you do the same thing. So here comes the answer. So we call that benzene. One for dicarboxylic acid, and the other one is ethane 1,2-diol. PET bottles cannot be stored. Used to store drainage cleanser containing corn anyway because PET reacts with strong alkaline. What is the reaction involved?
substitution
Yeah, substitution, is it? 哇，得啦，馮繼唔好講嘢啦，食咪啦，
sorry
嚇親啊嚇親啊，謝口明。What is the reaction involved?
Alkaline hydrolysis.
Alkaline hydrolysis. So what is the product? So besides this ethylene glycol, this one will remain there, not reacted. Okay, how about this? It will be changed to what? A type of carboxylate, okay? So you may find it quite hard to write down the Na plus, right? Na plus is still, you still draw it like this. While the COO O minus here, you draw it here to denote that it is a type of salt to be formed. Okay, is that clear? How about amide finally? (22) Final questions about 22. Nylon 66 can be made from dihexane diacid and another compound. What is the name of another compound? Lâm Sinh Hong.
Hexane 1,6-diamine.
Diamine. Okay, hexane.
Yes.
1,6-diamine. Amine, di, which means two. Amine. Amine functional group. So B, draw the repeating unit of nylon 66. So very. Now all of you please try your best to draw it now. So originally we have got this and also this. We are going to do it again. We have got 2N, right? So you are going to form ester linkage with the elimination of water will be formed. So you are going to cross them out, H2O, here, to form an amine linkage. Okay. How about the at both ends? As said before, I remove OH here, and also here, what have I removed? It is just NH2, right? I remove one H. So I remove H here, and I remove OH on the left-hand side. So here comes the repeating unit of the polyamide. This one of them is part of them is another half. Remember, you are going to draw the repeating unit. So never put an N here, no N. You're going to draw a repeating unit. C. Nylon 66 is a typical example of condensation polymer. Explain the meaning of the term condensation polymer. Deng Junhei, are you here? Deng Junhei.
Yes.
Yes, condensation.
Condensation polymer is the monomer molecules joined together repeatedly to form polymer molecules with the eliminations of the small molecules.
Yes. So we have got many monomers molecules joined together repeatedly through the condensation reaction. With the elimination of small molecules. So it is a polymer in which the many monomers molecules they join together repeating by condensation process with the elimination of small molecules. This is the keyword. Some elimination product will form. Two major uses of nylon 66. Tam Gunyao, are you here? Two major uses of nylon 66. Making what? Tam Gunyao. Tam Gunyao. Hồng Tránh Hiên. Hồng Tránh Hiên. Fishing lines. Okay, fishing lines and climbing ropes. Correct. Fabrics, okay, of clothes, etc. Okay. Now, I do hope this lesson will help you better understand about the polyester and polyamide. I found there may be drawing of the structure of the polymer or repeating unit being difficult to you. Spend some time on it, okay, before we meet this afternoon. Tell me your understanding of today's topic and any difficult parts. Now, this afternoon, we will go to the topic on soap and detergents, soapy detergent and soapless detergent. Okay, again, please type your level of understanding about the topics from 0 to 10 and any difficult parts that you may find. Do you find the drawing of a polymer difficult or manageable? Can manage? I can see most of you got it at least 6 marks. Okay, so we just stop it here. Okay. Now, all right, then see you guys. Now let's have a break. Bye bye.
呢度
係
我個好少嘅問題咧，就 ester linkage 同 ester 有咩分別？
ester linkage 個定義就係話將嗰個 ester 咧就做連結，即係話將兩隻唔同嘅 monomer 即係黐埋一齊，嗰、個位叫 ester linkage。如果你話 ester functional group 咧，就係、一個成粒嘅 molecule 邊，你就咁齋圈啊，話俾我聽佢入邊有咩功能基，咁咪叫 ester 咯。咁如果 ester linkage 咧，通常一咁樣講咧，就係講緊喺 polymer 入邊你見到嘅嘢啦，就叫 ester linkage。
哦，
得唔得？咁但係如果你平時你講一啲好簡單一個 simple 嘅 ester 嘅 material 例如咩 ethyl-phenolic 啊呢啲咁樣嘅話咧，咁我就通常嗌佢叫 ester 嘅。OK， 我哋好多時會咁樣嗌，個 practice 係有啲分別嘅。咁但係你話佢中間係咪叫 ester linkage 咧？如果我條問題，如果你個 focus 改咗係話唔係喎，呢一隻嘅物料咧係由 acid、carboxylic acid 同埋 alcohol 連結埋一齊，而佢連結嘅方法就係靠 ester 嘅話咧，我形容呢一個咧就叫 ester linkage。
哦，
即係你睇你個 focus 係想講咩啊？你想講話兩隻物料黐埋一齊，中間個接駁位係靠咩聯繫咧？嗱，咁我就 ester linkage。但如果唔係喎，我掉一粒 molecule 俾你，有冇聽入邊有咩功能基啦？咁你就話叫 ester functional group 咯。
咁即係隔離嘅嗰個咩 polyamide 都要寫為 amide linkage。
amide linkage，所以如果你講緊 polyamide 嘅話，就 amide linkage。你話入邊有咩 functional group 啊？佢嘅 functional group 就係叫做 amide 咯，你可以嗌 amide 都得啦。
唔該晒，唔該晒。
OK，好啦，拜拜。